Okay, we have a series of tests we're going to do here. Everything should remain the same in all the tests with the exception of these 4 boxes which are already pre-selected. These represent weights on a balanced beam. Our circle here represents our input energy, which is gravity driven. We have the information up here for the mass of the circle. And we have a block of ice here on a slab of ice. Its information is over here. It's approximately 1 kilogram, just a few fractions of a gram under. And we have a ruler on the ground here of 1 meter. So we're going to do some experiments by changing the mass of these 4 blocks to see how it impacts the energy that we transfer to this ice. So let's go ahead and run our test with the density of our 4 blocks set to 0.1 kilograms per meter square. You'll notice the energy in the 4 boxes is just a little over 1.15 joules. That's the energy. The mass of the 4 boxes is 0.05 kilograms. You can watch that as the acceleration occurs. So here we go. We can see our angular velocity increasing right here. We have an impact angular velocity of about 0.4 radians per second. And we notice here that we did happen to move the corner of the ice just a little bit past its starting point. So we did impart some energy. We did get it to move. I also want to draw attention to the fact that the friction and the restitution and the attraction of the 4 boxes is set to 0. So that the only thing we're changing here is the density. Let's reset it, and this time let's set our material of the 4 boxes to 1 kilogram. Increase it by a factor of 10. Here we go. Notice our angular velocity is increasing, 0.2, 0.3, and just above 0.3 when on the impact, and we get a little more energy transferred here also. So that we've actually moved that block of ice a little bit further, and all we've done is change the mass. So let's reset the system, and this time we'll change our mass density to 10 kilograms per meter squared. Now we've increased our overall mass for the 4 boxes to 5 kilograms. We'll notice that the calculated energy, which is the potential and kinetic energy, is 15 joules. You'll see that increase a little bit as they start moving because of the kinetic energy. So let's take a look at that. So we can see our joules going up a little bit here as the kinetic energy is transferred. We have our angular velocity increasing 0.11, 0.12, 0.13, 0.14, 0.15, and then we've hit it. And we've got a little bit more energy. We've pushed this block a little bit farther. Well, let's pull all the stops out, shall we? Let's go ahead and run our material density by another factor of 10 up to 100 kilograms per meter squared, which is the maximum we can try. And you've probably noticed in each of these tests that the acceleration factor is slower and slower because the moment of inertia is greater. And that's why our angular velocity is reducing on each test. But you notice now we've got 155 joules of energy. It's increasing slightly. Our angular velocity is 0.07, 0.08, 0.081 almost. Really slow. But look at all that energy that we're transferring and still transferring and still transferring. We've applied a much greater energy component to this box here, so much so that we've completely pushed it past 1 meter, and all we've done was increase the density of our balanced beam. Same amount of energy in all the tests going in, but we've changed the time. So tell me what you guys think of that.